Hi there. In this video I'm going to make a useless box, and as the name suggests, it is completely useless. I made a test mechanism using an SG90 servo, but this was not strong enough to flick the switch. Turns out that the switch requires 600 grams to get it to move. I needed to start again. I found a servo, DS3225, which can move 25 kilograms at 10 millimeters. The arm I made is 60 millimeters, so it will be able to move about 4.2 kilograms, more than enough for the switch. This did work, but I was running the servo on 5 volts through the Arduino, and sometimes it would stall the motor. I found a small buck converter, which I set to around 6.8 volts. And the servo ran very happily on this increased power supply. I designed a small PCB breakout board for use for this project using Easy EDA in a web browser. A week or so later, the PCBs turned up and looked very good. I'm using an Arduino Nano, but any microcontroller would work just as well. A few simple components and some headers for the Nano. Soldering the components onto the PCB. And adding the Arduino Nano. The code for the useless box, mostly finished. And uploaded. This is the final working test mechanism using the PCB and code. Now to cut out the box from what I thought was 6mm plywood. It's cutting using a 6mm diameter carbide 2 straight fluted router bit, running at 300mm per minute. The finished parts for the box. A hacksaw is used to cut through the tabs and release the parts. followed by some sanding. The internal corners have 3mm rads, so these needed to be removed using a file. Leaving a square corner. All of the parts laid out and ready for gluing together. Using some clamps to hold the box together as the glue sets. I bought some 6mm plywood from eBay, which turned out to be 1/4 inch, and I didn't check before I started, which was my fault. This made all the corners look a mess, so I had to make another box to the correct thickness. I gave it a cheeky coat of clear lacquer. Some small hinges and screws. Fixing the hinges in place using the tiny screws. Now to install the switch mechanism into the box. Already inside the box is the Nano on the PCB, the 2 buck converters, 5V and 6.8V, and a barrel jack connector, an automotive type switch with a wire and connector, the 25 kilo servo with a plywood finger attached to the plastic servo horn by 2 small wood screws, a red and a green 8mm LED with their wires and connectors. A 12V power supply plugs into the barrel jack socket at the back. The green light flashes 5 times to show it has booted up correctly. Works fine, but it still needs a warning plate. I made a plate using an aluminium business card and my homemade drag engraving bit. This is running at 20 times normal speed. It cut at 300 millimeters per minute and it took about 8 minutes to complete. Some very high, extra strength, double-sided sticky tape. This aluminium warning label was going nowhere. But does this thing work? If you've made it this far, well done. Please like and subscribe, or have a look at my website for information on this and other projects. And I will catch you in my next video.